All right. In this lesson, we're going to learn about the reaction that happens inside nuclear power plants, also the same reaction that happens inside nuclear weapons. And if you have trouble accessing the simulation, this will be the way for you to get all the answers you need. So here we have an atom right in the center of our screen. And we can see that it has lots of these red and gray particles. I can see over here that the red ones represent protons and the gray ones represent neutrons. And this is 235. U stands for uranium. When I hit the play button, we can see that the protons and the neutrons in uranium, they kind of are wiggling around. The protons are positively charged and they're trying to repel away from each other. It's the neutron's job to hold the atom together. And it's doing okay. But we can make it a lot harder for the neutrons to hold all those protons together by shooting it with another neutron. And pretty quickly we see what happens. I'll hit reset. So uranium-235 gets an extra neutron and then it splits apart. We can turn this into a chain reaction, which is what happens when you have many of these atoms together. So I'll go ahead and I'll make this one 100% uranium-235. And before I shoot, I want you to predict what do you think is going to happen when I hit the button. Think about it. Okay, let's see if you got it right. Notice how I had to only shoot the gun one time, and every single one of them reacted. This is called a chain reaction. If I want, I can go ahead and make it 100% uranium-238. But it's still uranium. That means it's got the same number of protons, but 238, bigger than 235, it's got additional neutrons. And if I shoot this one, that 238 turned into 239. I shoot it again. I shoot it again. Nothing's happening. All right? They're absorbing the neutron and not doing a chain reaction. I hit reset. So something to think about. Which situation would be the best for having nuclear power? 100% uranium-235, or maybe half and half, or no 235 and all 238. Which one would generate the most electricity? So make a prediction right now. A lot of people think, oh, having all uranium-235 would be best for inside a power plant because that's the one that does the reaction. So let's talk about what would happen there. We're going to add a containment vessel, which is basically a container, and it will fill it up with as many as it'll take. Looks like this container could hold 47 of those atoms. And if I hit the gun, yeah, that worked out great. It generated a lot of electricity. But what if I got greedy and I decided to make the container even bigger, right? Because the more atoms, the more energy that there would be. Hit this one. If I have too many uranium atoms, the chain reaction will go out of control. And that's exactly what an atomic bomb is. So in a nuclear power plant, we have to make sure that we don't have too many of those uranium-235 atoms close to each other. Otherwise, theoretically, it could make a bomb. Now, actually, there's no way for that to happen because in a nuclear power plant, they use only a tiny little bit of uranium-235 and a lot of uranium-238. So that's always under control.